let's, just for fun, call C1 again. I go through the same business. This becomes 2. This becomes 2. Okay, so I called C1 twice. Green chalk. There we go. I'm going to call C2. Well, we look it up. Oh, I'm sorry. It's a procedure call. So I have to evaluate the sub-expressions. So I look up C2. I follow the blue arrow, the top one, to this procedure. So I'm going to call this procedure. So I'm going to make a frame. Oh, sorry. My second call to C1 made a frame that I forgot to show you. Also extending this. Okay. So this one is E8. We're calling this procedure. Its right bubble points to E5. So E8 points to E5. There aren't any arguments, so E8 is empty. Now I go through this whole business again. Set bang. I'm looking in E8. This is the loc that I find in E5. So I'm going to change this from 0 to 1. How about glob? Well, it's not in E8, it's not in E5, it's not in E4. It is in E1. So I'm going to change that to 3. I end up returning 1, 3, the list 1, 3. Yes? Does the frame E6 disappear once you're done? The answer to that is the same as to all such questions. In principle, nothing ever disappears. But in the footnote, it says a scheme system has the right to recycle storage if it can prove that nothing points to it. So it doesn't sort of immediately disappear when we're finished. It sits around. But eventually, if we run out of memory, somebody will come along and recycle its space. Yeah? Does setbang list and plus create environments? No, because they're primitive procedures. And the rule is primitive procedures just happen by magic. They don't have any formal parameters. So there's nothing to bind in an environment. And it's not that they have to look anything up in an environment either, because remember, by the time we get to apply, we've already turned the argument sub-expressions into values. So we don't have any variables anymore. We only have values to deal with during the procedure call. Now, all of that I just said is a lie, really, because really, things like plus and list and so on are written in scheme. But they've been kind of compiled away. So as far as you're concerned, it's magic. Yes? Okay, special forms like set, bang, if, cond, etc. If and cond are special only because they delay the evaluation of some of their arguments and maybe don't evaluate them at all. So they don't change the diagram. Although in the course of doing them, we're going to have to evaluate things, so we're going to have to know what the current environment is. And we care to that extent. Set bang is different. Set bang changes the diagram. All those places where I crossed out a number and drew in another number, those are set bangs. And the effect of set bang, is visible forever after. So set bang and define and lambda and let do affect the diagram. Other questions? Yes? Oh, E7. I called C1 twice. And the second time I was in too much of a hurry. Whenever you call a procedure, it makes an environment. Okay? Does that answer that? Yeah. And then you're next. Yes. The question was, for set bang glob plus glob 1, do we have to look glob up twice? Yeah. It's just a coincidence that what we're setting glob to here is an expression that happens to involve glob. This could say set bang glob plus loc 1, or set bang glob plus pi 1, where that pi was a global variable, or something like that. So yeah. Yes, absolutely. The question was about concurrency implications, and in a few weeks, we're going to talk about exactly that. And yes, it makes a big difference. Somebody here? Or did I answer it? No volunteers. OK. Anyone? Yes? If you only have C1, you don't have access. That's right. You can't type into the scheme prompt anything about glob or loc. There's no, like, C1 colon loc or anything like that. The only way you can use those internal variables is to the extent that the procedure lets you. Yeah. I'm not quite sure I understand the question. It's about EQ, question mark. If you ask about two symbols, are they equal? You say EQ colon A, what? Two objects. Well, the only time in which there would be a question of a right bubble is if the two objects are procedures. Okay? You might be thinking that the arguments to EQ are expressions that might involve looking things up. But EQ is an ordinary procedure, not a special form. So its argument expressions have been turned into values before we call it. So all EQ does is it looks at the two arguments and says, are they the same place in memory? EQ is really simple. Other questions? OK. I think that's actually a question about next week. So if you're confused, don't worry about it. Yeah? Is there a way to move between environments in your program? Oh, that's such a good, interesting question. The answer is, as far as we're concerned, no. If you want to look up in the scheme reference manual, call with current continuation. Call hyphen with hyphen current hyphen continuation. Often abbreviated as call/cc. A continuation is kind of a reification, making into a thing, of where we're up to in the computation right now. So that includes what environment we're in and also what expression are we evaluating and where are we in the evaluation of that. So call/cc is this enormously, I mean, it's very simple to describe what it does, but it's really, really complicated to work out the implications. After they invented call/cc, it was like 3 iterations of the scheme reference manual before they got it right, the people who wrote the manual. So we don't use it in this class. It's one of 2 complicated things in the scheme. The other is macros. And if you're interested, after you read the thing in the reference manual, you can come ask me questions about it. But I advise you to do the coursework first. Other questions? Yes? OK, when we define C2 in blue chalk, how come it gets glob out of E1 rather than creating its own frame that has a glob in it? Well, I made C2 by invoking make count, right? That's this expression. Let's look up make count. It's this procedure. Let's look at its right bubble, E1. So when we call make count, we're going to extend E1, which we do with the frame E4. OK? Does that answer the question? You're still looking puzzled. When I defined C1, we also did that by calling make count. So we look up make count. It's this procedure. Its right bubble points to E1. So for the call to make count, I make a frame, E2, that extends E1. Every time we call make count, we're going to do it by extending E1. Right? E1 was created, yes, when we defined make count. You can tell that because it's in white chalk. Okay? Matching this white expression up here.